Hello, I'm back with another problem about series. In this case, we have this. For the absolute value of x less than 1, we have a equals x plus x squared plus x cubed and so on. And we have b equals x squared plus x to the fourth plus x to the sixth and so on. We are asked to find the limit of the ratio of b and a as x approaches 1 from the left. Now both a and b are geometric series because each term is a multiple of the previous term. For x, that would be a geometric series with a common ratio of x because x times x is x squared and x squared times x is x cubed. So Ra equals x. For b, we are given x squared plus x to the fourth plus x to the sixth and so on. So the common ratio here is x to the fourth over x squared or just x squared. Now for this two series, since they are both geometric, all we have to know now is if both of them converges. And if so, we can use the formula for a geometric series. Now we are asked to find the limit as x approaches 1 from the left, which means that x is less than 1. And that satisfies the criterion for a converging geometric series. Now remember that a geometric series converges, what am I writing? Geometric series converges when the common ratio is less than 1. And it converges to, let's call that S infinity as a sub 1 over 1 minus r. Where a sub 1 is the first term and r is the common ratio. Therefore, we can write a as a sub 1, so that's x here, over the common ratio that is Ra, which is x as well. Meanwhile, we can write b as the first term is x squared and the common ratio is x squared. So these are the expressions for a and b. Therefore, the limit that we are looking for as x approaches 1 from the left is equal to the limit as x approaches 1 from the left of x squared over 1 minus x squared divided by x over 1 minus x. We can simplify that by rewriting the division as a product of two expressions. So that becomes x squared over 1 minus x squared times 1 minus x over x. That's just the reciprocal of the denominator. Now we have x here and x in the numerator, so that cancels out and that leaves us just x. Meanwhile, 1 minus x squared is a difference of two squareds. And we know that the difference of two squares can be factored as a minus b times a plus b. Therefore, the 1 minus x in the denominator, the 1 minus x here will be cancelled out by that in the numerator. So this cancels out, leaving us with just 1 plus x in the denominator. Therefore, the entire thing becomes the limit of x over 1 plus x as x approaches 1 from the left, which is simply 1 plus or 1 over 1 plus 1 or 1 half. That's our final answer for this problem. It's a bit simple, I think. I think for a majority of the people who joined the contest that I've hosted, I think they found this an easy one. So if you are just starting to practice this one, I hope you improve your skills and immediately recognize that this is a geometric series and this can be expressed using the formula for the sum of a geometric series. Okay? That's it for this video. Thank you for watching and see you on the next one. Bye-bye.